5.3 scientific notation, you just want to make sure that the number in front of the decimal is between 1 and 10. Okay? And you use scientific notation to either write really super tiny small numbers or really large, huge, humongous numbers, like the distance that light travels in a year. So the advantage of using scientific notation is because when you start writing a lot of zeros with a lot of commas, it becomes such a large number that our brains find it harder to keep track of. Okay? Example number 1, you're going to see right away that I have to start counting how many zeros I have, how many sets of zeros between those commas. So I don't even like to, well, I mean, you can figure it out. This is obviously hundreds, thousands, millions, billions, trillions. So this is 5,680,000,000,000 miles, okay? So the easy thing to do with this is just to change it to scientific notation. So you're going to take the first 3 numbers that aren't zeros and write those down. And then you're going to add the decimal point somewhere so that the number in front of the decimal is between 1 and 10. So if you put it right here, it's going to be 56.8, right? So you can't put it there. So you have to put it here between the 5 and the 6. So it's 5.68. Then you're going to say times 10 to the power of, and then you got to count out how many spaces it was moved. And sometimes it helps to do this kind of thing. Now I've already lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Okay. All right. Any questions on example number 1? All right. Example number 2 is going to be a teeny tiny number. 0 point followed by 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Whew. So this is what we call decimal form, or decimal notation, yes. And this is obviously going the other direction. So this was a really large number, and its exponent ends up being positive. So this is a really small number. When we write it in scientific notation, its exponent is going to be negative. Okay? So let's see. We need to put the decimal between 2 numbers that's going to make the number in front of the decimal between 1 and 10. So it's going to be between the 2 and the 4, right? So it's going to be 2.4, and then we need to count how many spaces it moves from here to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, with these, they're pretty easy, but if you're counting it and you lose track, you might mess this up by 1 or 2 either direction. Okay, so just be careful, all right? Let's talk about going the other direction. So example number 3, going from, this was scientific notation. Let's talk about going from scientific notation, so 1.36 times 10 to the negative 6. And the directions will say something like, change to decimal form. Okay? So you start by writing the 1.36. And then since you have a negative exponent, you're going to move to the left. You're going to go 1, 2, 3, 4, 5, 6. That's where your decimal is going to end up at. You have to fill in all these zeros. And then it's usually just pretty standard to write a 0 out in front of that decimal. So the final answer would be 0 point, and then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5, and then the 1, 3, 6. Okay. Any questions on that? All right. So going both of these directions should be fairly easy for you. Let's look at one where they ask you to simplify by multiplying and or dividing. Okay, so 5,260 times 0.0682 times 86.1 divided by 0.420. All right, so the first thing they want you to do is change all of these to scientific notation. So just go one at a time. All right, so for this first factor, we want to put the decimal right here between the 5 and the 2, right? So we're going to say 5.26 times 10 to the, and it moved 3 times, so 10 to the 3rd. For the second factor, we want that decimal to be between the 6 and the 8, so it's going to be 6.82 times 10 to the, and we need to move it this direction, so it's negative 2 times. And then that third factor up there is just going to be 8.61, so we just moved it one spot, so times 10 to the 1st. So this was the first one, this was the second one, this is the third one. Okay. And then the denominator, we need the decimal point right there, right? So 4.2 times 10, this we went the other direction, so it should be 10 to the negative 1st. All right, so now we're going to group all of the number parts. So this one, so this part, and this part. I'm just showing you the way the book says to do it. So it says to go 5.26 times 6.82 times 8.61 times 10, and then you have to combine all these exponents of 3, negative 2, and 1. So 3 minus 2 is 1. 1 plus 1 is 2. And then let's keep that denominator there for us. Then the book says to round all of those numbers to the nearest whole number. So this 5.26, the nearest whole number is going to be either the number right below it, or, well, the number right below it or the number right above it. So the number right below it's 5, and the number right above it's 6. So is it closer to 5 or 6? 5. And then 6.82 is going to round to 7. So this is 5 times 7 times, and then 8.61 is going to round to 9. Times 10 to the 2nd, right? Yeah. And then we've got, in the denominator, 4.2 is closer to 4, right? Times 10 to the negative 1st. Okay. So at this point, you're just going to multiply 5 times 7 times 9. I did it on my calculator. I got 315. And then obviously 4. And I did one other step. See how we have this 10 to the negative first in the denominator? I moved it up here and added 1. So I'm going to make it times 10 to the third. Okay. Last step with the calculator, you're going to say 315 divided by 4. And then it gave me another decimal. It gave me 78.75 times 10 to the third. But if you want your final answer in scientific notation, this is technically not in scientific notation, you see that? You actually want that decimal right there. Okay, so you're going to say 7.875, and we moved it over 1 more, so we actually need to add 1 here, so this is times 10 to the fourth. So these get a little weird. You'll start off with all these easy problems in the book with